Alright, hello. If you haven't seen part 1 of this video, you may want to go back, and that way you can tell where all of these equations came from. But these top 3 equations came from a loop rule involving this circuit diagram here. And these bottom 3 equations came from node rules involving this same circuit diagram. So now what I'd like to do is actually solve this entire system of 6 equations with 6 unknowns by hand. That sounds intimidating, but it's really not that bad if we kind of take it step by step. So the first thing you're really going to want to do is stare at these equations for a good long time and try to figure out how to solve these. So one thing that you might notice is that this I5 here only appears in equation 5. So that means that we can wait until the very end to solve for I5 since it's only in this equation. So for now, we don't have to worry about this equation 5, and we can consider these other 5 equations with their 5 unknowns. So we basically just reduced the system of 6 equations with 6 unknowns to 5 equations with 5 unknowns. Now this top equation, this equation 1, kind of seems to be the most complicated here. So notice that it has I1, I4, and I6 in it, and again, I1 again, right? But the three variables that we're most interested in here are I1, I4, and I6, or the 3 unknowns we're most interested in. Okay, so we're going to want to solve for those 3. So essentially we have, we'd like to reduce the system to a system of essentially just 3 variables. What we're going to need to do then is, if of course we're trying to find 3 unknowns, we need 3 equations. Well, we can use this top equation, but we need 2 more equations. So one thing that we'll do here is we'll look at equations 2 and 4. It might seem mysterious why we're doing that, but hold on here just a second, because what you'll see is, okay, well, equation 2 has I4. That's also in equation 1, so that looks pretty good. I2, however, is not in equation 1, so that's kind of a troublesome unknown there. But we can use the help of equation 4 to solve for that I2. Notice that the troublesome I2 is also present in equation 4, but the other 2 variables, I1 and I4, are in equation 1. So they're okay. So what we're going to do is basically combine these 2 equations, equations 2 and 4, to create one equation that does not involve I2. Okay, so we're going to do that in just a second. But let's see if we can do something similar here with equations 3 and 6. Okay, so what you'll notice here is that equation 3 has this pesky I3 in it, which is not in the first equation. However, it does have I6, which is a safe variable because that is in equation 1. And I6 has that pesky I3, but the only other variables that it has are variables that are present in equation 1. So this is actually looking pretty good. Okay, so let's first combine these 2 equations, equations 2 and 4. And what I mean by that is that we're going to solve for I2 in 4. I'll try to write this out pretty small here. Solve for I2 in equation 4, and then plug it into equation 2. Okay, so let's go ahead and do that. So first thing that we do here, here's my equation 4. I'm going to solve for I2. So I2 is just simply I1 minus I4. Okay, so that's straightforward enough. Now let's take this I2 and we plug it into the I2 here in equation 2. So if I do that, what I get is 0 equals 5 plus 15 I4 minus 20 times, again, this I2, which is really just I1 minus I4. So notice that we've created one equation that now only has the variables present in equation 1. So that's exactly what we wanted to do. Now I can take this one more step here. I'm just going to kind of move to the right here instead of down to save some space. But what I can do is maybe solve for one of these variables. 20I1 equals 5 plus 35I4 if I combine everything accurately. And in fact, we can take this one step further, divide everything through by 20. And so what I'll have is that I1 is 5 over 20, or in other words, 1/4. Plus 35 over 20, in other words, 7/4, times I4. Okay, great. So right off the bat, we have kind of this nice equation here. Okay, so things are starting to look promising. So that was the combination of equations 2 and 4. Now let's do the same sort of thing with equations 3 and 6. So here we're going to solve for I3, okay, again, that pesky variable, in equation 6. Now, I could have solved for I3 and 3 and then plug that into 6. I'm just doing it this way for no particular reason. And so then I'm going to plug into equation 3. Okay, great. So let's do that. So here it is in equation 6. I'm going to solve for I3. This is I1 minus I6. Okay. And I'm going to take this I3 and I plug it into the I3 that's up here. So now I have 0 equals negative 5 minus 30 times I3, which is just I1 minus I6, plus 12I6. Okay, so that's actually starting to look pretty good at this point. If I combine things a little bit further, what I get is that 5 plus 30I1 equals 42 times I6. Okay, great. So now we have a system of 3 equations and 3 unknowns. In fact, I may want to, well, I'll wait to combine this later. Okay, but here are my 3 equations. My equations are equation 1 up here with I1, I4, I6, right here with I1 and I4, and right here with I1 and I6. Okay, so things are actually starting to look really pretty good at this point. Okay, so now what I'd like to do is go back to my equation 1. Okay, so first off, let's combine these I1s just to make things seem a little bit prettier. So equation 1 implies that 0 equals 20 minus, okay, so I have a 10I1 and a 20I1 that combines to a 30I1 minus 15I4 minus 12I6. Believe it or not, we're actually almost through with the problem at this point. It's really just kind of cranking through the numbers at this point. Okay, so first we've combined these I1s. Now we're going to substitute in this equation right here where we've already solved for I1. We're going to plug this in, the I1 that's in this equation right here. Okay, so let's go ahead and do that right now so that what we have, in fact, let me kind of clean this up here a little bit. Perhaps I'll move everything up a little bit so that we can see kind of what's going on. Okay, so here's what we're going to do now. We've got, okay, yeah, so we're going to put in the I1 at this point. So now I've got 0, oops, so I have 0 equals 20 minus, okay, so I'm plugging in the I1 that I have right up here. So I have 1/4 times 30, which gives me a 30 over 4, minus 7/4 times 30, which gives me a 210 over 4 times I4. Sorry, this is a 210 times I4. And then we still have the minus 15I4 and the minus 12I6 right here. And so now let's combine some things here. If we combine all of our numbers and we solve for I6, what we get is that I6 is 25/24 minus 135 over 24 I4. Okay, excellent. So things are really starting to come together here. In fact, this equation is perhaps so important, I'm going to label it because I'm going to use it again in just a second. Alright, so now that we have that, let's go back to this 42I6 is 5 plus 30I1. Okay, again I have what my I1 is here, so I'm going to take that and plug it in to the I1 here, like this. Okay, so, so what I've got then coming from this is kind of a separate step here, is we're going to have 42I6, I'm going to start with that on the left-hand side. That equals 5 plus 30I1, where your I1 is exactly what we've written up there. So it's going to be 5 plus 30 times a fourth, which is just 30/4, plus 210 over 4 times I4, like that. Okay, so we have this whole thing here. And now I can go ahead and maybe just clean this up a little bit, I guess. So let's do that. So 42I6 is 25 over 2, if I combine those coefficients, plus 105 over 2 times I4. Okay, so all I've done is just clean that up a little bit. Now my final step, I'm going to take the I6 that I have right here, and I'm going to plug it in to the I6 that I have right here. Because if I do that, then I'm going to have only numbers and things involving I4, which is exactly what I want to do. So this is going to be 42 times I6, which is this big kind of ugly thing, 25 over 24 minus 135 over 24 times I4. That equals 25 over 2 plus 105 over 2 I4. Okay, so then, hooray, we get something if we go ahead and actually calculate this. 25 over 231. That is what my I4 is. Now that I have that, I can plug this into this equation, figure out what my I6 is. I can plug it into this equation, figure out what my I1 is. Then I can go all the way back to equation 1, because I have my I4, my I6, my I1 at this point. I can go ahead and basically solve all of the variables at this point for all of the unknowns, and then we're done. We have solved the entire equation. I've also put in a link here just below the video to how Wolfram Alpha would solve a problem like this, where I have substitute instead of I1, I have the letter A, I2 is the letter B, and so on. But you can check that out as well if you're interested in not doing it by hand. Thanks for watching.